This is the engineering exploration course which we were going through under the guidance of Sir Raghuraja Adi. We worked as a team of 4 members to complete the project of Hurdle's physical car. To understand the intellect on this, let's explore through the problem definition. The problem definition goes by: design a semi-automatic gaming machine which is portable, user-friendly and entertaining. The machine should be light-weighted with the dimensions of 2 x 2 x 2 feet. The dimensions of the car should be 10 x 5 feet and should complete 2 levels to win the game. The cost of the machine should not exceed 4,000 rupees. The car should be controlled by smartphone app controller, should be movable and steerable. It should sense the collisions with the obstacles. The obstacles should be moving randomly. The machine should indicate the path and display the completion of the race. It should also control the hurdles and maintain the targets. Function tree and function clustering. The gaming machine contains lane, obstacles, moving car and sensing part. The lane contains both static obstacles and dynamic obstacles. The function of the car is steering, sensing obstacles, acceleration and brake. In sensing of the obstacles and sensing targets. The subsystem identified in this project are car and lane. We have generated 4 different concepts for this project using different mechanisms for the obstacles. And using PugChat with proper justifications, we have selected this concept for our implementation. Virtual implementation. The 3D model of the entire system goes by here. This is the 3D model for the obstacles. This is the 3D model of the car. This is the circuit diagram for the car, which consists of 4 motors, Arduino Nano, battery, Bluetooth module. This is the simple circuit diagram for the lane. It contains of a DC motor, Arduino. This is the flowchart for the entire system. As soon as we start the game, we receive the Bluetooth module for both car Arduino Nano and lane Arduino Mega. As the Arduino Mega, the obstacle movements, it start upward movement and the downward movement. The car Arduino Nano, the IR sensors, when the input is x equal to 0, it shows as red, and out. If the input x equal to 1, it shows as green and win. As soon as it indicates either red or green, the game ends. The mill of materials. Here are the list of the materials which are required for building this machine. It consists of a DC motor which is 12 volts of 60 RPM. We require 3 DC motors. Base foam board 2 x 2 x 2 feet 1, which can be fabricated using laser cutting. Arduino Mega for lane and Arduino Nano for car. L clamp to fix the obstacles. Limit switch. L293D lithium polymer battery. HC05 Bluetooth module. BO motor, servo motor, micro switch, wheels, steering. This all are used for building of the car. Motor sizing and battery sizing. The total number of motors used are 3. Mass of the shaft is 0.1 kg. The radius of the shaft is 0.75 centimeters. The coefficient between nylon rod and nylon is 0.25. Acceleration due to gravity is equal to 9.8 meter per second square. Factor of safety F equal to 1.5. Force, which is equals to torque by radius, equal to 2 divided by 0.75, which gives 2.7 newtons, and the torque goes on with 2 kg centimeter. The DC motor is 60 rated RPM at 12 volts. The maximum current consumed by the DC motor is 300 milliampere. Battery capacity is equals to maximum current consumption into number of working hours, which gives us as 600 ampere hours. A battery of 12 volts is required. We have selected 3 DC motors, which gives torque as 2 kg centimeter, RPM as 60, and current consumption is 300 milliampere, and the voltage required is 12 volts. The function specification of the entire system. The car runs through the lane of width 12.5 centimeter. The lane consists of 3 hurdles situated at the side of the lane in every stage. The 60 RPM DC motor is used for the movement of the car. As the car moves, it should be controlled in a way that it overcomes itself from the hurdles. The function of the obstacles is upward and downward movement. The car has a Bluetooth sensor module that uses to sense the contact of the car to the hurdles. In case the car comes in contact with any of the hurdles, the game ends with the blink of the red LED. If the car is able to reach the end of the lane without coming in contact with any of the hurdles, it displays green LED and it shows as win. Here is the modeling and simulation video for the car.
This is a circuit for the car with 4 motors. Through the Bluetooth module, when the signal is 1, all the motors will spin so that the car goes forward. If I press 2, all will spin in the reverse direction. If I press 3, half will spin and half will not. Half will be at 0 RPM. When I press 4, the car turns right. Half will spin and half will not spin. The input is 5. Half will spin in one direction, half will in the opposite direction, so that it turns where it's standing. The 6 is the same, but the direction is reversed.
And at the end, the simulation video for the lane goes by. A simple DC motor. When we give the input as 1, the movement will be in the upward direction, and if we give the signal as 2 or 0, the movement will be in the downward direction. At the end, to conclude this presentation, I would like to tell the experience of mine in this project. It was indeed a benefit to the learning outcome we have all experienced. Here we successfully come to an end with the realization of the growth in the perspective of erudition. Engineering is not just about the subject, but it is also about the project. This is the end to this project, and thank you.